Have you ever looked up at those massive power lines crisscrossing the country and wondered what they're made of? Most people would guess copper, right? It's famous for being a great conductor of electricity. But if you guessed copper, you'd be wrong. The vast majority of those high-voltage transmission lines are actually made of aluminum. So why choose aluminum over the king of conductivity? The answer is a fascinating mix of physics, economics, and a little bit of history. Let's get the big question out of the way first. Isn't copper a better conductor than aluminum? Yes, it is. On a volume-for-volume basis, copper is significantly more conductive. But here's where it gets interesting. When you compare them by weight, aluminum is actually twice as conductive as copper. Think about it this way. To carry the same amount of electricity, an aluminum wire needs to be thicker than a copper one. But that thicker aluminum wire will still weigh only half as much as the copper equivalent. Now, imagine you're building a power grid that stretches for thousands of miles. Weight is a huge deal. Lighter wires mean you don't need as many support towers, and the towers you do build can be less robust and cheaper. When you're dealing with a national scale, saving on millions of massive steel towers adds up to an astronomical amount of money. The lower weight of aluminum translates directly into lower infrastructure costs, making it the clear economic winner for long-distance power transmission. But wait, isn't aluminum that soft metal used for soda cans? How can it possibly withstand the incredible tension and harsh weather that power lines endure? You're right, pure aluminum isn't very strong. That's why power lines aren't just simple aluminum wires. They're actually a clever composite material called aluminum conductor steel reinforced, or a CSR. The core of the cable is made of high-strength steel strands, which bear most of the mechanical load and prevent the line from stretching or snapping. The outer layers are then wrapped with multiple strands of highly conductive aluminum. This design gives you the best of both worlds, the strength of steel and the lightweight conductivity of aluminum. It's a brilliant piece of engineering that makes our power grid possible. The widespread shift to aluminum was also heavily influenced by history. During World War II, copper was a critical strategic material, essential for things like shell casings and wiring in military equipment. It was in extremely high demand and short supply for civilian use. This forced engineers to look for alternatives, and aluminum became the go-to substitute for electrical applications, including the rapidly expanding power grid. The war proved that aluminum was not just a temporary fix, but a viable and often superior long-term solution. The infrastructure built during that era set the standard for decades to come. So if aluminum is so great, why is the wiring inside your house still made of copper? This comes down to scale and properties. Inside the walls of your home, weight isn't a concern, and you're not building massive support towers. Here, copper's superior conductivity per volume is a major advantage. It allows for thinner wires, which are easier to run through walls and fit into crowded electrical boxes. Copper is also less prone to expansion and contraction with temperature changes, and it forms more reliable connections at terminals, reducing fire risk. For the specific demands of residential wiring, copper is simply the safer and more practical choice. Looking to the future, the game might change again. Researchers are constantly developing new materials, like carbon nanotube or graphene-based conductors, which could one day be lighter and more efficient than anything we have today. We're also seeing a rise in high-voltage direct current, or HVDC lines, which can transmit power over even longer distances with fewer losses. The materials used in these next-generation grids will need to meet even higher standards of performance and efficiency. In the end, the story of our power lines isn't about finding the single best metal. It's about making the smartest engineering choice for the job. For sending massive amounts of power over vast distances, aluminum's incredible weight-to-conductivity ratio makes it the champion. But for the intricate and confined spaces within our homes, copper's compact efficiency still reigns supreme. It's a perfect example of how different materials are chosen to solve specific problems in the most effective way possible. Thanks for watching. If you found this interesting, Don't forget to like this video and subscribe for more deep dives into the hidden engineering that powers our world. See you next time.